In this video, we will be discussing the internal rate of return, or IRR, as a method of capital budgeting. Remember that capital budgeting is the process of evaluating potential investments to decide which ones to accept and which to decline. Your understanding of the internal rate of return is dependent on your understanding of net present value, or NPV, so make sure to watch the net present value video first if you haven't already. Remember that when NPV is used, you must choose a required rate of return. That required rate of return influences the net present value calculation. A higher required rate of return will make the net present value smaller, and a lower required rate of return will make the net present value higher. The internal rate of return is the required rate of return that results in a $0 net present value. The internal rate of return is an inherent return that the business can make on the given investment. The calculation of IRR is probably the most involved of the capital budgeting methods that we've looked at so far, and we only consider the case when cash flows are even. If cash flows are uneven, meaning a different amount of cash is earned in each year, then IRR will need to be calculated using either the guess and check method or using a computer or financial calculator. Let's consider the same situation we have had many times throughout our capital budgeting examples. The purchase of equipment for $100,000 that will provide $25,000 in cash flows for the next 5 years. If cash flows are even, as they are here, the first step in calculating IRR is to calculate the payback period. Remember that the payback period is just the initial investment divided by the annual cash flows. We have $100,000 divided by $25,000, which equals 4. This is the factor we will be searching for in the table momentarily. Step 2 is to look up the present value of an annuity of $1 table and to look for the table factor in the appropriate row. Here we have the table titled the present value of an annuity of $1. We use this table because there are equal $25,000 cash flows that happen at regular intervals, which is the definition of an annuity. Look at the row related to the number of periods in your problem. In this case, we have 5 years, so we look at the row for 5 periods. Now search for the table factor from the payback period calculation of 4 somewhere in the 5th row. Most likely, you won't be able to find the payback period exactly. We see that 4 appears somewhere between the interest rates of 7.5% and 8%, but the table factor is a little bit closer to 4 when the interest rate is 8%. Depending on your teacher's preferences, you may either list the internal rate of return as a range, between 7.5 and 8%, or you might choose the closer value, 8% in this case. For our purposes, I'm going to say that the IRR is about 8%. Indeed, if you were to calculate the IRR for this problem using a computer, it comes to 7.93%, so 8% is a pretty good estimation for us. Okay, now that we have found the IRR to be 8%, how do we choose whether or not this is a good investment? We must compare the IRR to the company's required rate of return. If the IRR is higher than the company's required rate of return, they should accept the investment. And if the IRR is lower than the company's required rate of return, they should decline the investment. In the net present value video, we said that this company's required rate of return was 6%, and this investment provides an 8% rate of return, so they should accept this investment. If the company doesn't have a required rate of return, they can compare the IRR of this investment to the IRR on other competing investments and choose the investment that provides the highest IRR if they are mutually exclusive. If you were to go ahead and calculate the net present value using an 8% required rate of return, you should get some value very close to 0. Theoretically, it should be $0, but of course we rounded the IRR, so we would only get some value very close to 0. It's important to note that both IRR and NPV will always give the same decision rule, meaning that if IRR is above the required rate of return, NPV will also be positive. Finally, for the advantages and disadvantages of the internal rate of return. For advantages, IRR does take into consideration the time value of money, just like NPV, so that is a positive. Unlike NPV, a required rate of return does not need to be determined for IRR. A company can simply look at a number of different investments and choose the one or ones that have the highest IRR to invest in. Disadvantages include that the IRR ignores the actual dollar amount of benefits. A project providing 10 times as much cash flow as another project with the same IRR would appear equal if IRR was the only form of measurement used. There's also an implicit assumption that the future cash flows can be reinvested at the internal rate of return, which is often not a practicable assumption. For example, if the IRR was 8%, there is an assumption that cash flows earned throughout the period could be reinvested at 8%, which may or may not be the case. IRR also runs into problems when cash flows change signs in the period, meaning they switch from a positive to a negative or vice versa. This can create a situation where multiple IRRs are possible, which makes interpretation difficult. Alright, that wraps up our video discussing the internal rate of return, which is the last of the capital budgeting methods we will be looking at.